4.2. In this section, we're going to start learning how to calculate the area under the curve. Alright, before that, let's look at the notation of summation, which is theorem 4.2. Alright, the first formula is sigma I is your variable. It starts from 1 to n is an integer. So it's increased in sequence order 1, 2, 3, and so on. C is constant. So if you have sum of some number from I equal to 1 to n, it's just C times n. Alright, look at example. The first example here, I have sigma I start from 1 to 30, negative 18. So think of C here is negative 18. So I'm going to apply that formula. So it's going to be negative 18 times n. My n here is 30. Alright, so it's going to be multiplied by 30. Alright, and then if you multiply that, you should get negative 540. That is an example of the first property. Alright, now let's look at the second one. If you have a sigma I start from 1 to n of I, you're just gonna multiply n times n plus 1 over 2. Alright, look at the third one. If it's I squared, you're gonna use this formula. If it's I to the cube, you're gonna use this formula. If you have a constant times a sub I, you can bring out the constant and calculate the sum here and multiply by constant. If you have two terms, you can break it out to sigma of a sub I plus or minus sigma of b sub I. Right? So let's look at our second example. I have sigma I from 1 to 16. 5i minus 4. This is two terms, as you can see. I'm going to apply property number 6 here. Right? I'm going to use property number 6. So I'm going to have sigma I from 1 to 16, 5i minus sigma I from 1 to 16 and 4. Now I have two terms, alright? Now I'm going to apply, let's see, the first term, 5 is constant, so I'm going to bring it out. So this one is property number 5, right? I can bring out the constant. So I'm going to do that. I'm going to have 5 sigma I from 1 to 16i, alright? The second term I have sigma I from 1 to 16 of number 4, so I'm going to apply the first formula here. So it's going to be C is 4, right? And N is 16. Okay, now I'm not finished with the first term. I have sigma I from 1 to 16 of I, so I'm going to use the second property here. So I'm going to have 5 times my n here is 16, alright? So it's going to be 16 plus 1 over 2, alright? I'm using the second property here for the first term, minus 4 times 16, alright? So you just calculate this. The answer should be 616. Alright, that's the answer. Alright, let's look at the next one. Again, the next one I have two terms. I'm going to use property number 6. Alright, so I'm going to have sigma I from 1 to 15 I cube minus sigma I from 1 to 15 2i. Alright, the first term here, I'm going to use the fourth property here. My n is 15. Alright, my n is 15. I'm going to use the fourth property there. So I'm going to have 15 square 15 plus 1 square over 4, which is the fourth property. This second term, I'm going to bring out the 2. That is property number 5. I can bring out the K. Alright, and then I have sigma I from 1 to 15 of I. I'm going to use property number 2 for this second term. Alright, so I'm going to have, let me write everything for now. So this is 16 square over 4 minus 2. Again, 2 times this whole thing. Alright, so that's going to be I, which is my n is 15. So 15, alright, 15 plus 1 over 2. Alright, and then you simplify this. If you simplify this, you should get 14,160. Alright, so I would like you to read theorem 4.3 yourself. Alright, make sure you read that. The next definition is the definition of area of a region in the plane. If you have to find an area of the region under the plane, if it's circle, you would use pi r square. If it's a rectangle, you would use length times width. If it's triangle, you would use 1/2 base times height. However, sometimes the region under the plane might not be a perfect shape that you have formula, so you need to apply this limit. The idea of this definition is that you're gonna divide the region into small rectangle. So n is number of rectangle and delta x is the width of each rectangle, and then apply limit as n go to infinity, which means you have so many rectangle, and then we need to use the summation notation here. We will see that in 4.3, but let's practice some more. Alright. Hi everyone, let's continue our section 4.2. Let's go to the fourth example. Alright, let's say the fourth example here, I have limit of this expression. I'm gonna bring out the constant, which is 81 over 4, right? So I'm gonna bring out 81 over 4, then I will have a limit as n go to infinity of n square n plus 1 quantity square over n to the 4th. Alright, next step I'm gonna reduce the n square here, and here I end up with n square. Alright, so then I'm gonna have 81 over 4 limit as n go to infinity. I'm gonna expand this term, then I'm gonna have n square plus 2n plus 1 over n square. Alright, next step I'm gonna rewrite this. Alright, so I'm gonna have 81 over 4 limit as n go to infinity, n square over n square plus 2n over n square plus 1 over n square. Alright, now I'm going to take a limit. Oh, before that, let's simplify it. I'm going to simplify this a little bit. So this is just 1 plus 2 over n plus 1 over n square. Alright, now I'm going to take a limit as n go to infinity. As n go to infinity, I will have 0 here, 0 here. Limit as n go infinity of 1 is just 1. So I have 81 over 4 times 1, which is 81 over 4. Alright, let's look at the next example. The last example, example 5. They want us to rewrite that expression without summation notation. So they don't want to have this summation notation. Alright, again, j is your variable here. J starts from 1 to n. N can be any constant. Just think of it as a constant, right? So first thing I'm thinking, I'm going to take out the constant, which is 1 over n squared. I left with sigma j from 1 to n 4j plus 3. Alright, I take out the constant, in this case is n squared. Here I have two terms, so I'm gonna apply number 6. Right, I'm gonna apply number 6. So I'm gonna have 1 over n squared time, I have to be very careful with the parenthesis here, sigma j from 1 to n 4j plus sigma j from 1 to n of 3. Right? I have to be careful with parentheses here because 1 over n multiply to everything in here. Alright? So I have two terms. The first term I can bring out the constant. The second term I'm going to apply the first property here. Right? So I'm going to have 1 over n squared. The 4 only apply for the first term right here. So I'm going to put parentheses. Alright? Sigma j from 1 to n j. I have to put parentheses because the 4 only apply for the first term. The second term I'm going to apply the first property here. So it's going to be 3 times n. Right? Now the first term here I have variable j, so I'm going to apply the second property here. We call it I, but it's j here. Alright? So I'm going to have 1 over n squared. It's going to be n plus 1 over 2. So 4 times n plus 1 over 2 plus 3n. This example, make sure you put parentheses in the right place. So this 4 multiplied to this whole thing here. Alright, let's see. I can reduce the 2 and the 4. So I got my 2 here. Alright, so I end up with 1 over n squared. I'm going to multiply 2n to the parentheses. So it's going to be 2n squared plus 2n. Okay, this 2n, let's see, multiply to everything in here. So it's going to be 2n squared plus 2n. Alright, plus 3n. It's a bit messy, but you can see it. Alright, then I'm going to divide n squared to all of them. Right, so I'm going to have 2n squared over n squared plus 2n over n squared plus 3n over n squared. Alright, the first term is just going to be, let's see, 2 plus 2 over n plus 3 over n. Alright, you can leave your answer as this 3 term, or I did simplify it. It's going to be 2n plus 5 over n. Alright, so we finished chapter 4.2. I'll see you next time. Bye.